so section 1 for exponential functions. Guys, remember just now from section 1.3, we had already talked about it a little, right? So, general information for an exponential function is f of x equals whatever b to the x or a to the x, okay? Where the base a or b is what? A positive constant, okay? So that means b is what? Greater than 0, but b cannot be what? 1, okay? b cannot be 1. So that means b is either between 0 to 1 or b is what? Greater than 1, okay? Alright, so exponential function, we know the base is a constant, the exponent is a variable x, okay? Well, we have these subcases, okay, subcases. We did this already, right? If x equals n, which is a positive integer, this is different, okay? Just now we talked about a power function. Now, this is exponential function, they're different, okay? When x equals n is a positive integer, b to the nth power gives us b times g times g, n factors of b, right? If x equals 0, b to 0 is 1, okay? So, when x equals 0, guys, x equals 0, what is the function f of x? Function f of x become what? 1. It's a constant function, okay? So, if x equal, this is not a, sorry, it's not a function, f of x equals 1.
F is 0.
Yeah, f of 0 equals 1. It's a point, okay? It's a value, y value, okay? Never mind, I said something, yeah, this is wrong, okay? If x equals negative n, we should have a b to the negative nth power, and then a is a positive integer. That gives us 1 over what? B to the nth power, right? Can you see this clearly? 1 over b to the nth power. Oh.
Expand again.
Yeah. What?
Expand again.
So, b to the negative nth power is defined by 1 over b to the nth power. This is a definition for negative exponent. Okay, this is defined like this. Okay, it is defined like this. Alright, how about if x is not an integer, not a negative integer, it's not an integer. So x could be a rational number, p over q, where p and q are both integers. So p over q gives us a rational number, and then our exponential function becomes b to the what? B to the x, where x equals p over q, okay? And they give us what? Radical number, right? Radical numbers. B to the, this is q's root. This is too small, okay? I'm going to rewrite it here. P2 over q equals q's root of b to the p's power. Well, you can rewrite it as q's root of b to the p's power. Okay, this is what we learned from the algebra. Okay, this line is this. Okay, this is too small. Okay, I just rewrite it. Okay. And how about x is what? X is an irrational number. So, for example, x equals square root of 3, or x equals pi. Okay, then we're not going to talk about in this section. We don't talk about it. Okay, so here, just want to let you know that x could be what? All real numbers. Okay, here x could be all real numbers. So that's the domain for what? Exponential function. Later we'll sketch the graph of the exponential function. You will see x could be all real numbers. Okay. All right. Now this example. Sketch y equals 2 to the x power, y equals 4 to the x power, y equals when base b equals 1, base b equals 1/2, 1/4, okay? You see this b is greater than 1, this b equals 1, this b equals what? Less than 1, but greater than 0. Sketch all of these exponential functions, okay? I will give you a couple minutes to think about it, and then we'll do it together, okay? Think about it. If I let you sketch y equals 2 to the x power, do you know how to sketch it? Use floating point method. Try find x values and then compute y values and sketch. start from the first one. Graph y equals 2 to the x. What x values can we choose? Can we choose 0? X equals 0, can we? Yes or no? That's right, yeah. So when x equals 0, y equals what? 2 to the 0, which is 1. So 0, 1 is a key point for us. 0, 0, 1. Oh, this point is on our graph. So key point 0, 1. Can we choose x equals 1? So that gives us y equals what? 2. So 1 and 2 key point. Okay? How about x equals 2, y equals 4? Of course, we can do that, of course. 2 and 4, another key point is here. So we can choose when x equals positive real numbers. And we did when x equals 0. Can we choose when x equals a negative number? Let's try, okay? How about when x equals negative 1? Y will be 1/2, right? 2 to the negative 1 is 1/2. X equals negative 1, y is 1/2. Oh, so it is a point here. How about x equals negative 2? 2 to the negative 2 give us 1 over 2 squared. What is that? 1 over 4. So that means when x equals negative 2, y is 1/4, which is slightly lower, than this point, right? Shorter than this point. So you can imagine that when x becomes bigger and bigger, how about y? Smaller and smaller. But my question is, can y equals any negative real number cross this line? No. Yeah, okay.
So it approaches an asymptote at
Well, x,
where it's a 0.
yeah, well, y equals 0, which is x-axis, right? It's not touching, okay? It looks like a touching, it's not, okay? So this is a briefly graph for what? For y equals 2 to the x power. You guys agree with the graph? Okay.
I have a question.
Sure.
Why can b never be negative? Is it because you can't divide with the square root of a negative number or something?
No, you can't. It's just clarification.
See, if b equals a negative real number to the x power, let's see, what is the reason why b cannot be negative. B cannot. X could be. X could be all real numbers. So negative 2 to the x power, logarithm function is a inverse function of exponential function. So the corresponding inverse function for this exponential function is f of x equals log of x to the what? The base negative 2. Okay. However, we don't have any base for logarithm function which is negative number either. But I didn't really answer your question, did I? I didn't.
It's not important.
No, I have to think about it. Negative 2 to the x power. No, we don't have this. Negative 2 to the x power.
Is it impossible?
X could be a fraction, right? X could be a fraction. If, say, for example, x equals 1/2, this function f of x will become negative 2 to the 1/2. And that gives us a square root of 1/2. See, for example, if x
Show on the graph.
Yeah.
I just realized something. I mean, that's true too.
I thought it had some.
Professor,
what's that?
I'm feeling a little dizzy. Do you mind if I go get a drink of water?
Go. Okay. Yeah, so x could be all real number.
But not only that, but that.
Is he all right? Oh my God. I hope he will be fine. He will be fine.
But not only that, but with a negative exponent, the graph's going to look very different. Well, negative base is going to look very different. It's going to go up on the y-axis and down and up and down because negative 2 to the first power is negative 2.
Yes.
Squared is 4.
Yeah.
Negative 2 cubed is negative 8.
Yeah.
And that's a problem.
It's not stable, right? It's not stable. You can still choose x equals 1 that give you a value, but it's not going to be a smooth function looks like
It's
that.
still a function.
Yeah, it's still a function, but for exponential function, we just don't choose the base is less than 0.
It's basically useless, right?
What?
It's basically useless.
The base is useless?
No, if it's negative, the base is useless. Because it goes all over the place, is basically what you're saying.
That goes to everywhere, that's for x, right? It doesn't, but this base, I will think about this question and answer that to you after class, okay?
You should move on.
Yeah. Okay. But here, that's a very good question to remind us. This will never be a negative number for everyone. Okay, we know no negative base for exponential function and logarithm function. Okay, logarithm function you'll see the base is b here. Okay, log of x to base b. This base cannot be negative either. Okay, no. Okay, good. I'll let you know. Okay, Simon. Okay, in the later time. All right. Y equals 4 to the x power. Same thing, guys. Have you tried? X equals 0, give us 1, right? See? Same point will show up on the graph of this function. X equals 1, give us 4, 1, 4. Okay, see it is slightly top. This point is top. Well, x equals negative 1, it gives us what? 1/4. Negative 1, 1/4, slightly lower. Okay, so for y equals 4 to the x, we can use just the 3 points because we know the tendency of it, okay? So it is going to be, looks like this. Yes, it's steeper, right? This is y equals what? 4 to the x. Guys, I'm going to ask you another question. If I'm going to let you graph y equals 6 to the x power, can you imagine the graph is going to be more steeper, right? Well, this part goes this, right? Even down a little bit, right? Even down a little bit.
It chases the asymptote faster and faster.
Yes, yes. All right, so these two examples, okay, they are when the base b are what? Greater than 1. Right, see? 2 is greater than 1, base 4 is greater than 1, okay? So we can see that, okay, if the base b is greater than 1, in this case, we're going to have what kind of function? Increasing or decreasing? Increasing from the left to the right, increasing function. And also, do you see that 0, 1 is always a key point for what? Exponential function. So this is one of the characteristics, okay? 0, 1 is a key point for all exponential function, okay? They all pass through point 0, 1. And then for, if the base b is greater than 1, okay? This is the case, in general, y equals b to the x power, b is greater than 1, okay? And then we'll have increasing function, okay? And then we can tell that, what else can you think of? Increasing, and then pass through point 0, 1, what else? Is it symmetric with which axis? Yes or no? No, it's not symmetric with, no, okay, so no. So yeah, so this is when base b is greater than 1, right? Are you all right? Are you feeling?
Yeah, I think I'm all right. I'm just feeling dizzy.
Oh, okay. Oh, wait, you didn't sleep well last night?
I slept like a baby. I don't know anything. I'm sorry.
That's fine. Okay, so the third question is y equals 1 to the x power when base b equals 1. Remember just now I said base b cannot be 1. Why? Because now you see if base b equals 1,
It just describes a line with y equals 1.
you're right. So y equals 1 to the x power, whatever x, this is x is, it is 1. So what is y equals 1? Y equals 1 is a horizontal line in the xy plane, right? So this is y equals 1 to the x power. So for exponential function, we're not talking about this case when b equals 1. We don't talk about this case. We only talk about when either b is greater than 1 or b is what? Between 0 and 1. Okay? So that's why, yeah, there are two cases, okay? Okay, you'll see on the next page, okay? All right, for these two functions, y equals 1/2 x and y equals 1/4 x, let's graph this quickly, okay, quickly. X equals 0 give us what? 1, see? Same point, okay? Key point. How about when x equals 1, guys? Y equals what? 1/2.
It's the mirror of it's the first function mirrored of the
y-axis. Very good. Okay, so see, this is key point. This is a key point. However, when x equals -1, what is 1/2 to the -1's power? 1 over 1/2 is what? 2. So negative 1, 2. Do you see the 3 key points? This point, and this point, right? Right, Simon? Right. That's cool, yeah, that's cool, okay? Of course, negative 2 and then goes to 4, and 4. Okay, so this is briefly the graph of what? Y equals 1/2 x. And it's just like Graham just said, so this was just like, what?
Near about the y-axis.
Yeah, near about y will reflect about the y-axis. But it's not the transformation part, okay? It's just looks like this.
Happens to be.
Yeah. Okay. And then how about y equals 1/4 x? Can you imagine? I'm not gonna do this. Can you imagine? It will pass through point what? X equals 1 give us 1/4. X equals 0 give us 0.1. X equals negative 1 give us positive 4, right? Uh-oh. It has to pass through this point 0.1, okay? Okay, so this red one is y equals 1/4 to the what? X power. Right? Okay, and now let's look at these two functions. Y equals 1/2 to the x power, y equals 1/4 to the x power. Both of these two functions, the base b is what? The base b is y equals b to the x when b is what? Between 0 and what? 1, okay? Can you tell the graphs, are they increasing or decreasing from the left to right? They're decreasing, okay? They also pass through what? Point 0.1, because 0.1 is like a key point for every exponential function, okay? All right, guys, now summarize. Increasing case, decreasing case, this function we don't call it exponential function. No, okay? B equals 1. This is not even exponent. Well, maybe the new book calls this is a y equals 1 to the x, but we don't study it. There's no meaning for it. It doesn't mean anything to study a horizontal line, right? No, so we don't study this case. Usually we consider exponential function only has these two cases. Okay. All right. Now, law of exponents. Okay. You learned this before, I believe. Okay. B to the x plus y's power equals b to the x times b to y. Well, reversely, I believe you learned this. For two exponential expressions, same base, what do? We keep the same base, but we add up what? The exponent, right? How about the two exponential expression division? Keep the same base b, but subtract the exponent, right? Remember this? Reversely, same thing, okay? This is a two-way equation, okay? And how about b to the x power, then to the y's power? It gives us the b to the what? X times y's power, right? And then if we have a multiplication to the x power, okay? So it's like a distributed with x to each of the factor give us a to the x times what? B to the x, okay? So these are the very basic laws of exponent. Now I'm going to give you about 5 minutes, 3 to 5 minutes to simplify. Use the laws of exponent to rewrite and simplify these expressions. Okay, what are the expressions? Question A. 4 to the negative 3's power divided by 2 to the negative 8's power. Simplify it. Question B. 1 over cube root of x to the 4th power. Question C. This is the third question. It's just a screenshot from the book, okay? So it looks like this is question 1, question 2, A and B. It doesn't matter, okay? So yeah, this is the A from question 2. Simplify 8 to the 4th third power. Question B. Simplify x times 3 times x squared, then cube. this fraction, they don't even have the same base. Can you do division directly?
I don't think so.
No. So can you make them have the same base?
I don't know how.
2 is already very basic. It's a prime number. Small is a prime number. Can we make 4 to the negative 3 a 2 to something?
Yeah.
Yep. How? 2 to the negative 8, this is, I don't think, it's already very basic, right? 2 is the base. 4 to the negative 3. Can we make this part to be 2 to something? What's the relationship between 4?
2 to the negative second.
Yeah. First, we make 4 to be 2 squared. Now we have a 2. Remember the law of exponent is telling us b to the x power, then y power equals b to the, what? X times y. What's 2 times negative 3?
Maybe it's this.
Can you do it from here? Same base, right?
Yeah. But I solved it slightly differently. I solved it by just, because you can get the inverse exponent, just flip them.
Yes.
And that's just 2 to the 8th over 4 to the 3rd.
Yes. That's fine. That's fine. So I think Graham did this way equals 2 to the 8th. To get rid of the negative exponent directly, 4 to the cube, right? Now you can make it this way, 2 to the 6th, and then that gives you a 2 square is 4, right? Yeah. Okay, so if we are using this option, how about the exponent, guys? It's negative minus what? Negative 8, careful. And then this gives us 2 to the negative 6 plus 8, right? What is it? Positive 2, 4. Did you get this question correct? You didn't have time to think. I'm doing too fast.
I need to see it laid out step by step. I don't want to do most of this stuff.
Question B, we have a fraction, we have a radical expression. So how can we rewrite it? Dakota, you have a suggestion?
I know I didn't want to say it. So that could be written as x to the negative 4 over 3.
That's a final answer. But can you do it step by step?
Okay, so do you want to get the radical out first into the fraction?
Yes.
Okay, x4 over 3. I was trying to do it the other way around. It wasn't working. Okay, and then in William, since it's reciprocal, we can say it's x to the negative 4.
Agree with Dakota, everybody? Yeah, first, cube root of x to the 4th, the index of the radicals always going to be on the numerator position as the rational exponent.
Is that one of the rules for exponents?
Yes, it's always like this. So 3 is the bottom, denominator, 4 it is the numerator for the fraction, and because this is 1 over, we can rewrite it as x to the negative 4 over 3. Right? And how about this question, 8 to the 4 thirds? That looks easy, right? So how? Can we rewrite it as in a radical expression way? Can we? Cube root of what? 8 to the 4th power, right? Now how can we keep on simplify it? Oh, okay. So you say, let's use calculator, 8 to the 4th power and cube root.
We can use without a calculator. I have a better idea.
Yeah, yeah, good idea.
8 is the same thing as 2 cubed. So then we can say it's 2 cubed in the power, so 3 times 4 over 3, so it's just 2 to the 4th.
Yes, okay. Well, since we're already here, okay, let's start from here, okay? So cube root of 2 to the cube times 4 what is this, actually? This is cube root of, I would say, 2 to the 4th power, then cube. Can you, everybody accept this? 2 to the cube to the 4th power, we switch the power because it's equals 2 to the 3 times 4, right? It's the same thing as 4 times 3, so 2 to the 4 to the cube. Why? Because,
That lets you remove the cube root.
yeah, cube root of a cube cancel out, right? Cube root of a cube,
I get that.
you get that, right? So,
Why
let's,
switch it again?
because this is a cube root, if we have a cube here,
I know why you switch it, but how did you get it to switch? I don't.
Addition, because addition and multiplication are commutative. You can switch, change the.
2 to the 3, 4 equals 2 to the 3 times 4, right? Does that mean? And then we can rewrite it as 4 times 3, right? So we can rewrite this as 2 to the 1st power then to the cube. Because multiplication satisfies commutative.
Right.
Or if you don't want this, okay, use a calculator, do 8 to the 1st power, or
It's 4,000.
yeah, then the cube root. That's also fine. The answer is 16, right?
Yes.
And how about this question? X times 3x squared to the cube. We have a parenthesis, right? Deal with parenthesis first. And then this is what? A multiplication. So which law, which rule did you use? Number 4, right? Yeah, we can use number 4. So x times what? 3 to the cube times x to the square to the cube, right? You go with this, everybody? Okay, so 3 to the cube is what? 27 times x. What is x to the square to the cube?
X to the 6.
X to the 6. Can we do further? It is going to be 27 times x to the what? 7th power. Are these too hard? Well, if you forget about the laws, I would suggest you just after class, okay? Just go over those laws and then keep on working the practice questions, okay? We have questions from the book list that I give you, and also we have homework assignments. Also, another thing is I want to say, whenever you buy a code with an e-book, or you buy a physical book with a code, you have the book, right? I would suggest you guys read our textbook examples after school, after class, okay? Because in class, I just pick up some questions. It cannot cover every single examples from the textbook. So I would say that read the textbook examples. That also will help you to understand the math concept, okay? Okay, so I would say we have 2 more questions. I would leave this 3rd page next time, but let's work on this last concept. Natural exponential function y equals e to the x. When the base b equals e, which is a special number, okay, we call this exponential function natural exponential function. And then this number e, okay, is an irrational number approximately equals 2.718 blah blah blah. Okay, so can you imagine the shape of the natural exponential function? We learned about the two cases for the exponential function. Which case it is? It is an increasing case or the decreasing case? Is this number e greater than 1? Yes. So the graph of the natural exponential function will pass through point 0.01. Also, when x equals 1, y will be e, right? What is e? A number between 2 and 3, right? Somewhere there. So briefly, the graph for y equals e to the x will be what looks like this. Y equals e to the x. Right, guys? All right, so we still have 2 more questions. One question is to graph this function by transformation. Okay, sketch a graph. So what is a standard function? Can you think of what is a standard function do you want to use? Y e to the x. And then we do transformations. I would say that we come back next week, okay? We can review this, okay? Do this problem as a review, okay? And then find the domain of this function, okay? Find the domain of the function. If we have a fraction, we have to make sure that the denominator cannot be 0, right? So for these two problems, I don't think we have enough time to completely finish them, in detail. I don't want to in a rush, okay? And plus section 1.5 is I think it's a short section. I don't think it's a long section. So I would say that for these two last questions from section 1.4, go home and try by yourself, okay? So next time when we go over these two problems, okay, you have already done it, okay, you can, you have already, think about them, so we can do them together easily, okay? So these are your homework assignment you can think of, and then next time, we're gonna, for the next class, we'll do this problem at first, then we keep on moving to section 1.5, okay? Another thing, guys, let me pause the video.